In order to show how a cooling system, as for example in a refrigerator, functions, this film first explains the principle of evaporative cooling. Evaporative cooling. Nature, or rather the human body, provides the best explanation for evaporative cooling. The human body must be kept at a steady temperature of approximately 37 degrees Celsius. Under physical strain, for example when jogging, the body heats up. The temperature rises and the body must be cooled so that it does not overheat. The skin is the human body's air conditioning system. It has sweat glands which are able to moisten the skin surface with water. The higher the heat, the more water is transported to the skin surface. Due to the large surface, the water can easily evaporate from the skin. The water thus changes its state of aggregation from a liquid to a gaseous state. This process extracts a lot of energy from the body in the form of heat. The surplus heat is thus transferred to the environment. That means that the body is able to adjust its own temperature rather exactly. Water is used as refrigerant. If the refrigerant eventually runs low, it's refilled. But how does a refrigerator function? How does a system function that's not refilled? The closed refrigerant circuit. In contrast to the human body, a closed circuit is needed for cooling systems. In such a circuit, the refrigerant must be made to liquefy and evaporate again. Only gas is suitable for this purpose. The main components. The main components of the refrigeration cycle: the compressor, the condenser, the capillary tube, and the evaporator. The gaseous refrigerant is transported to the condenser and compressed to a higher pressure by a Danfoss compressor. The capillary tube, which makes it possible to build up pressure, is at the end of the condenser. During the compression, heat is produced which is transferred to the environment through the surface of the condenser. The refrigerant is gradually liquefied by the heat emission. The completely liquefied refrigerant is now outside the capillary tube. It enters the evaporator where a lower pressure prevails. The liquid refrigerant is now evaporating. During this process, the heat is extracted from the cooling compartment. Let's remember the human body and the skin. There, heat is extracted from the body when the water evaporates. Now that the refrigerant has completely evaporated again, it is sucked in by the compressor and compressed another time. The refrigeration cycle closes without losing the refrigerant. But what does it look like in our refrigerator? Here it is just this principle of the closed refrigerant circuit which is applied. The compressor transports the gaseous refrigerant to the condenser. The condenser is the black frame on the back of the equipment. The refrigerant is liquefied by the heat emission to the environment. The liquid refrigerant enters the evaporator through the capillary tube. It reduces the refrigerant's pressure. And only through this the refrigerant can absorb heat and evaporate. This is exactly what happens in the evaporator. The refrigerant takes up the heat from the cooling compartment and becomes gaseous. Now the completely gaseous refrigerant is sucked in by the compressor again and the cycle begins anew. Two refrigerants are used mainly in household cooling appliances: the synthetic R134A and the natural isobutane, also referred to as R600A. In Europe, isobutane has become the widely used refrigerant over the last 10 years due to its favourable environmental properties. The compressor label always indicates which refrigerant is used. Thus, with its innovative and environmentally favourable compressors, Danfoss has belonged to one of the leading manufacturers of hermetic compressors worldwide for generations.